In this video, we're going to cover section 4.1 on exponential functions. I have a few examples, and the first one is graphing by transformations. We want to graph the function y is equal to 5 raised to the negative x plus 2. And in this case, I've actually already drawn the graph of our base function here, y is equal to 5 raised to the x. Notice that when x is 0, we get y is 1, so I plotted that point. And when x is 1, we get y is 5, so I plotted that as well, and drew the exponential function connecting those two values. After that, we can try to draw y is equal to 5 raised to the negative x, because what's the first thing that happens to x is we multiply it by a negative 1. So our next step is to write out or draw out y is equal to 5 raised to the negative x. Well, what does that do? It just flips across the y-axis. So we can draw that here. And this is the y is equal to 5 raised to the negative x exponential function. After that, to finish this problem off, we want to graph y is equal to 5 raised to the negative x plus 2. So let's take our previous function that we just drew and add 2 everywhere. So we move this up 2. Move this value up 2. And then we can draw our exponential function here. And notice that, right, we had a horizontal asymptote at y equals 0 before. Now we have a horizontal asymptote at y equals 2. So this will continue and approach but never reach y is equal to. And that's it for graphing y is equal to 5 raised to the negative x plus 2 by transformations. I want to continue on with a second example from this section. It's a completely different type, though. We want to look at an investment problem, and we'll look at the compound interest formula in this problem. So for number 2 here, let's suppose that someone invests at an interest rate, invests $1,000 at an interest rate of 2.5% per year, compounded daily. And then if so, find the value of the investment after the given number of years. And for the first one, I want to find what the value would be after 2 years. So for this, we need to know the compound interest formula. And that compound interest formula is a of t equal to p times 1 plus r over n raised to the n times t. Here, p is the principal amount, that is the invested amount, it's your starting amount. 1 plus r over n, r is your interest rate. N is the number of times you compound per year, and that shows up twice. And then t is the number of years. Okay, so let's go ahead and plug everything in. Right? We want to find a of 2 in this case, because that's what our question asks. This is equal to the principal amount. Well, we invested $1,000. 1 plus r is the interest rate. We were told the interest rate was 2.5%, so that would be 0.025 as a decimal. We're going to divide by n. N is the number of times we compound per year. Since we are compounding daily, that is 365 times. And then we plug in n again up here in the exponent, and we multiply that by the number of years, 2. So this becomes 1,000 times 1 plus 0.0006849,315. Thank you, calculators. And all of that raised to 730, right? 365 times 2. We plug that in to the calculator. We end up getting $1,051.27. Usually in these problems, we'll round to the nearest cent, so that's what I've done here. That's really it. So for any of these types of problems, it'll tell you the number of years that you want to find the final investment at. And so you just plug in that number of years into this formula with the other corresponding data to get your answer.